All right, so solving quadratic equations, we start with just multiplying binomials. Remember, this is FOIL. So like I said, it starts kind of easy in here, but you have the first, outer, inner, and last. That is just an acronym. What it really is you're multiplying everything in the left one times everything in the right one, and that's a way to make sure you do that. So I do the first one, x times x is x squared. I do the next one, the outside ones, x times 5 is 5x. The inside ones, 3 times x is 3x. And then the last ones, 3 times 5 would be 15. Now, what this does, like I said, is to make sure you multiply everything in the left one times everything in the right one. So I've taken this x times both of these, and then I took this 3 times both of these. Like I said, it's just a reminder to do that. I write it like this because those are common terms, so I can combine them and add them up. So I have x squared plus 8x plus 15, okay? So most of y'all know foiling, so I won't spend too much time on that. But what we're going to main focus probably today is factoring, and factoring is the opposite of foiling, the inverse. So we are going to go from this back into the two binomials like this. So what you do on that one, you have x squared plus 5x plus 6. This is the easier factoring to start, but what you're doing here is you're trying to get it to look like two binomials. X times x is x squared, and then you say what multiplies to be the last number and adds up to be the middle number. So you're saying what multiplies to be 6 and adds up to be 5. So this would be, 2 and 3? I do this little scissors or X things over here just as a visual representation. What multiplies to be positive 6 and adds up to be 5. So 2 times 3 is 6, and 2 plus 3 is 5. So then I come over here and I write plus 2 and plus 3. And you could always foil to check your answer. Okay. But this is just the opposite of foiling. So let's do another one of those. X squared minus 7x plus 12. So what multiplies to be 12 and adds up to be negative 7. Again, you put x and x right there because x times x would be x squared. If you get stuck, I know 12's, this one's like not hard, but if you ever get stuck, you can do 12. Just divide it by 1 in your calculator, you get 12. Divide it by 2 in your calculator, you get 6. Divide it by 3, you get in your calculator, you get 4. Just start dividing it by 1. Divide it by 2, divide it by 3, divide it by 4, divide it by 5 until you see your answer. So on this one, it's going to be negative 3 and negative 4. Negative 3 times negative 4 is positive 12. Negative 3 plus negative 4 would be negative 7. Okay. Most of y'all don't struggle too much with that factoring, but just to refresh over it, what multiplies to be the last number and adds up to be the middle number? All right, they have like perfect square, or I'm sorry, they have like these shortcuts. I don't teach the shortcuts too much because I feel like y'all get good enough at these just to do them. So like what multiplies to be 9 and adds up to be 6, that would be 3 and 3, right? 3 times 3 is 9, 3 plus 3 is 6. So x times x is x squared, positive 3 and positive 3. Oops. The shortcut here is this one will always break down to be, how do you know if it's a shortcut one? I don't like to teach shortcuts because I don't want to confuse you. But the way you know it's a shortcut is if this number is a perfect square, as in, the square root of that real quick off the top of your head, then it's most likely a perfect square, okay? So what they do is you can write it like this and say, okay, x times x is x squared, 3 times 3 is 9, and since this sign is positive, you put a plus in the middle. Again, I don't really like the shortcuts because I like to just try to teach one way to do everything. I think that makes it less confusing. But if you were doing the shortcut like on this one, you would say, okay, it's a perfect square. X times x is x squared. 4 times 4 is 16. This is a minus, so it's negative 4. But to me, don't try to worry too much about learning the shortcuts. It does not take that long to say, okay, what multiplies to be 16 and adds up to be negative 8. Well, negative 4 times negative 4 is positive 16. Negative 4 plus negative 4 is negative 8. And Alex would probably count either of those answers correct. They're the same thing. The other kind of version of a shortcut is the difference of squares. The difference of squares is always, again, as soon as you see this right here be a perfect square, you probably know something's up. But when you have two terms, it's usually something a little bit different too. So on this one, what you're actually looking at is x times x is x squared. 5 times 5 is 25. There is no middle term, so it adds up to be 0. You do plus 5 and minus 5. They do say the difference of squares because it's like the square root of 25 is 5, and then the difference would be plus and a minus. So it's like what adds up to be negative 25 and adds up to be 0. So again, when you see those perfect square numbers, like, and the perfect square, the easy way to remember the perfect square is if you can do the square root real fast in your head. It's like x squared minus 49. As soon as you see 2, you're probably thinking two terms, like 2 terms. It's going to be like one of these, x times x squared. 7 times 7 is 49, and a plus and a minus. All right, you put it into an equation. Most of y'all have seen this before. It's called the zero product property. The zero product property says that it doesn't, if this one goes to 0, 0 times anything would be 0. Or if this one goes to 0, anything times 0 would be 0. So as long as one of them is 0, then you get 0 for your answer. So anytime it's set equal to 0, what you can do is just figure out if this one goes 0 or if this one goes to 0, either of those could be my answer. So I subtract 2 from both sides on this, and I get negative 2. I add 3 on this side, and I get positive 3. So those are my 2 answers for this. So the reason you have 2 answers is because it's x squared. That means you can have up to 2 different answers. So now we are going to start solving the equation of these. Anytime you have 2 terms, okay, anytime I have 2 terms with this, the 0 we're not really paying attention to on this because you always set it equal to 0. So the rules on these are you always set it equal to 0, okay, and then you check for a GCF. That's going to be the number 1 step. I'm going to show you a shortcut on the hard ones, not a shortcut, an easier way to do it. But always check for a GCF. That's very important to these. So when I look at the GCF of these and these, I can factor out a 2x from both of these. I can divide a 2 and an x out of both of these. So 2 divided by 2 is 1. I have 2 x's. I take away 1, so there's just an x left. 8 divided by 2 is 4. I take away the x. What you should be able to do is distribute this back through, and it should equal this one to check your answer, kind of, but you are taking or dividing it by 2x. So you're taking a 2x from all those things. Now I have, this looks a little bit different than the problem we just did up there, but I have 2 factors that equal 0. So I set 2x equal to 0 and x plus 4 equal to 0. On this one, I divide by 2 and get x equals 0. On this one, I subtract 4 and get negative 4. Okay. Very common to forget to do the 0 on that one just because it's a little different, but you have 2 factors. Like you have this being multiplied by this, just like you had this being multiplied by this. So when you have 2 things being multiplied, one of them can equal 0 and the whole thing will equal 0. On this one, again, first thing you always want to do is set it equal to 0. It's already set equal to 0, so now we're going to check for GCF. I can divide all these by 2, right? Always check for GCF because that makes you have smaller numbers to work with. So now I go through my factoring steps. What multiplies to be negative 3 and adds up to be 2. I go straight to my factoring steps because I have 1, 2, 3 terms right here, right? So I know I got to look at that. That would be positive 3 and negative 1. So x times x is x squared. Negative 1 times positive 3 would be negative 3. Negative 1 plus 3 would be positive 2. Once you get to this point where you have the different factors, you can set it equal to 0. That 2 doesn't matter because technically, I'm going to erase this, but you could divide everything by 2 and like those would go away. So that doesn't do anything. All we have to do is set where there's an x. If there's an x, I set it equal to 0. So x minus, oh, I guess I didn't really need to write that step. I was thinking that I divided it by 2, but we'll leave that on there just to show you, I guess. My bad. Wrote an extra step there, but all you really have to do is set the ones with the x equal to 0. Those numbers always go away because you can just divide it out. So you add 1 to both sides and subtract 3, so you get 1 and negative 3. Just like linear equations, if you can take those and plug it back into the original to check your answer. The tests are not super long, so if you you'll be able to go do the whole test and go back and check your answers if you want to. That is something you can do. I'm gonna skip that one, I think. Yeah, let's go to this one. All right, so I said the first step of these is always to set it equal to 0. So we want to get everything on one side. The reason I know to set it equal to 0 is because I have an x squared and an x, okay? Talking about solving quadratic equations, when you have an x squared and an x, get everything on one side because you got two kind of terms to work with there. So I'm going to subtract 6x and subtract 2 from both sides. So I get 2x squared minus 6x, and then 8 minus 2 would be positive 6. So again, our steps: set equal to 0, check for GCF, and then do your factoring steps. So on this one, there is a GCF. I can divide 2, 6, and 6 by 2. So I get x squared minus 3x plus 3 equals 0. That doesn't factor. I hate that doesn't factor. AI let me down here. Technically, that would be... no, this is a solve one. I was trying to think of something that I could do to change it real quick or fix it. Make it easy to change. I think if we do, can we change this to, sorry, I don't like to change problems in the middle of them, but if we change this to a 10, I think it'll work. So that'd be negative 8, divided by 2 would be 4. All right, so we're looking at what multiplies to be positive 3 and adds up to be negative 4. X times x is x squared. So I have negative 3 and negative 1, right? Negative 3 times negative 1 would be positive 3. Negative 3 plus negative 1 would be negative 4. So again, you don't really have to worry about that 2 outside. You're only looking at where x's are. So add 3 to both sides and add 1 to both sides. I bet that was supposed to be 6x minus 2. All right, so this one had an x squared and an x, so you set everything equal to 0. If you have a problem with just an x squared in it, you don't have to really set it equal to 0 because there's only an x squared. So just get the x squared by itself, and then the opposite of squared is the square root. The square root, we're asking what number squared is 16. Well, that's the same thing as square root. What number squared equals 16? It is 4, but it's not just 4. Anybody remember what to put here? You got to put plus or minus because 4 squared is 16, and negative 4 squared is also 16. So you have two answers. You have negative 4 and positive 4. I think Alex will probably make you write it like this. I hate that they don't put a plus or minus button there. But anytime, the rule here is anytime you do the square root inside an equation, you put plus or minus. Anytime you do the square root inside an equation, you have to put plus or minus. Because the squared kind of cancels out the negative. Negative 4 times negative 4 is also 16. All right, so when you're on a problem like this, the first instinct on this a lot of times is to FOIL this out and do x minus 3 times x minus 3. But this is just something squared equals 9. Just like this one up here was something squared equals 16. So you have something squared equals 9. What you can just do is take the square root to start. And the square root and the square will cancel out on this side. The square root of 9 is 3. And I'm going to put plus or minus because I did do the square root inside an equation. 3 times 3 is 9, and negative 3 times negative 3 is 9. And then to get x completely by itself, I'm going to add 3 to both sides. So I have x equals 3 plus or minus 3. Now that looks funny, but what you're actually doing is 3 plus 3 is 6, and 3 minus 3 is 0. That's my two answers, 6 and 0. So that, remember, plus or minus is actually two different things. You do 3 plus 3 and 3 minus 3. On this one, we want to get the squared term by itself first. Okay, you want to get this part by itself first. So I'm going to divide both sides by 2. And I get x minus 1 squared equals 9. And now, again, I have something squared equals 9. So once you have the squared term, you can do the square root. The square and the square root cancel each other out. So I have x minus 1. Square root of 9 is 3, and I write plus or minus because I did the square root. Now to get x by itself, I'm going to add 1 to both sides, so I get 1 plus or minus 3. 1 plus 3 is 4. 1 minus 3 is negative 2. All right, one more of these. So here, to get the squared term by itself, I divide by 3 and get x plus 4 squared equals 9. By the way, technically you could FOIL this out and it will still work. It just creates a ton of work. And you can FOIL it out and then you have to factor it. But just try to think about, I have something squared equals a number. If something squared, you can do the square root. The square root and the square cancel out. So I have x plus 4 equals square root of 9 is 3, plus or minus, because I did the square root. So to finish this out, I subtract 4 from both sides, and I get x equals negative 4 plus or minus 3. That's two different answers. Negative 4 plus 3 is negative 1. Negative 4 minus 3 is negative 7. All right, I want to look at something real quick. Give me just a second. I feel like they didn't give me the hard problems to do. Okay, we're going back to this one. Sorry, I don't want to go to the next thing yet. But now I got to come up with my own because AI can't do math. Oh no. Okay, give me 2 seconds to come up with one here because this isn't hard or easy to do in my head. I know you're seeing the answer, but that's fine. We got to learn how to work it out. Okay. On this one, well, I told you to set it equal to 0, so it's already set equal to 0. The second step is to check for GCF. Well, I can't divide 2, 9, and 5 by anything. So on this one, there's a few different ways to solve it. You might have learned the AC method or trial and check and trial or trial and check or whatever, or maybe even factor by grouping. I'm going to teach you a different way that's a little bit easier. I always like that when we factor, we end up with a problem that looks like this. Like I said, I try to do everything one way so that it doesn't have that many different steps. So I'm going to do the same thing. I'm going to try to make it right like this. So I'm going to do, since we have a number in front of x squared here, I'm going to do 2 times negative 5. And this is negative 10. And I don't care how you do this on the test. Like, if my way is easier, but that's fine. If you want to do factor by grouping or check and trial or AC method or any of those, that's fine. So I'm going to multiply the first and the last number, and I need it to multiply to be negative 10 and add up to be 9. Okay? So my two numbers here would be positive 10 and negative 1. Okay, so this is kind of similar to what we did. The only thing different right here is we multiplied that front number because there's a number in front of x squared. Here's where my way is a little bit different, and this is the part you mess up when you go to do it on your own. I'm going to write, since I multiplied by 2 by the beginning, I'm going to write 2x at the beginning of both of these. And then I'm going to write my numbers, plus 10 minus 1. Now, this obviously isn't right because if I FOILed it back out, 2x times 2x would be 4x squared. Can I divide 2 and 10 by something? I can divide those both by 2. So what if I get x plus 5 and 2 and 1 I can't divide by anything besides 1, and now I have my answer. So what happens here is I multiplied by 2 at the beginning. So like I multiplied by 2 to make the problem easier to work, so I have to divide by 2 at the end to make it back to where it was supposed to be. Okay, we'll do a couple more of these. So if you do it this way, that's fine. Just make sure you write whatever this number is at the beginning of both of them, and then you'll simplify. All right, but you still have to solve these both. X plus 5 equals 0. 2x minus 1 equals 0. And then you are going to subtract 5. On this one, you got to do an extra step because you add 1 to both sides and then divide by 2. So x is 1/2. So you still get 2 answers on these. I was looking up some problems so I don't have to think. But there's some certain problems I need. We haven't done a big number. Let's do a big number. I don't know if this works. All right. We don't have to do equal to 0. I think y'all know how to do that part. First thing, always check for GCF. So I can divide 16, 20, and 6. I can divide them all by 2, right? So I get 8x squared minus 10x minus 3. So now I'm going to do 8 times negative 3. So what multiplies to be negative 24 and adds up to be negative 10? Would be negative 6 and negative 4? Nope. That didn't work, did it? Oh, how about negative 12 and positive 2? Right, negative 12 times positive 2 would be negative 24. Negative 12 plus 2 would be negative 10. It can't be negative 6 times negative 4 because that would be positive 24. So we know it's not that. Okay, so when you go to do this on your own, we multiplied by 8 at the beginning, so I'm going to write 8x at the beginning of both of these. And then I write negative 12 and positive 2. What can I divide? What can I divide 8 and 12 both by? 4, right? No, 3. And then 8 and 2 I can divide both by 2. And this one doesn't have an equal sign, so that's my answer. Now wait though, I said a minute ago we multiplied by 2 and then we divided by 2. On this one we multiplied by 8 and then we divided by 4 and 2, which is 8, right? So it may not, they'll always match up one way or another like that. We multiplied by 8, so we divided by 4 and 2 to get back to where we were. Okay, it'll always, always, always work out like that. I was trying to find one with a bigger number here, because we have not done one with a bigger number, because I just want to show you if you get stuck a little bit what happens. All right, on this one, 5, 27, and 10, there is nothing common that we can divide those all by, so I do 5 times 10 is positive 50. What multiplies to be positive 50 and adds up to be negative 27? If you get stuck, go to the calculator. You will have access to a calculator on the test. Alex calculator will be there. Divide it by 1. Divide it by 2. Divide it by 3. That doesn't work. Divide it by 4. That doesn't work. Divide it by 5. Divide it by 6. Divide it by 7. Just divide it a couple times and you'll start to see your answers here. So do I see anything that adds or subtract to be 27? Right there, right? 2 and 25. So negative 2, negative 25. So negative 2 times negative 25 is positive 50. Negative 2 minus 25 would be negative 27. So I come over here. Since there is a number in front of x squared, I write 5x in both these spots. And then I write the two numbers we came up with, minus 2 and minus 25. Five and 2 I cannot simplify. 5 and 25 I can divide by 5 though. And once again, we multiplied by 5 at the beginning, so we divided by 5 at the end. Does anybody want me to show the factor by grouping method just to refresh over that? Yes. Okay. I am not one of those math professors that wants you to do it my way. I know my way's better, so I don't need you telling me. Kidding. I don't care which way you do it, just get the right answer. So this is, sorry, 7x squared, 17, 12. Okay. This is just an alternate way to do these problems. You can actually do any factoring problem like this if you want. Starts the same way, 7 times negative 12. So what multiplies to be negative 84 and adds up to be 17? Again, I don't know what this is off the top of my head. I don't think, yeah, I do. Well, I don't know. Divided by 1, divided by 2, divided by 3. Does that work? I think it does, 28. Divided by 4, divided by 5, divided by 6. Does 6 go into it? 7, 18? 14. Divided by 7 is 12. Divided by 8 doesn't work. Divided by 9 doesn't work. Does this one not factor? I'm just pulling stuff off Google, so I didn't have to think anything off the top of my head. I don't think this one works. Oh, wait, 4 and 21. Y'all aren't stopping me? It's 8 a.m. on Monday morning. We're doing math. You can help me out here. 4 and 21. 21 minus 4. 21 times negative 4 would be negative 84. 21 minus 4 would be 17. But you see, like, I obviously was having a moment there. Like, it does not take that long to come up with the factors when you have a calculator. Just make a list like that, and you can go through it and figure out what they are. Okay. Factor by grouping. Here's where it goes a little bit differently. I'm going to write 7x squared. Instead of writing 17x, I'm going to separate it out into the two factors we came out with. I do 21x minus 4x minus 12. So I'm separating that 17x out to be 21 minus 4, which is 17. So I'm not changing anything. I'm just separating it out to be two different factors. Okay? All right, so now we go to the factor by grouping step. The factor by grouping step says that I group the first two together and group the last two together. And it does not matter if you wrote negative 4 and 21, it will still work out correctly. Like if you switched them in negative 4 plus 21x, it'd still work out fine. So now you group them, and we're going to factor each one individually. The red one, I can factor out a 7x. So I get x plus 3. And the green one, I can factor out a negative 4. And I get x plus 3. If you do this correctly, these will match. If you do it correctly, those will match. That's how you know you did it right. So my final answer, what I do is I take the stuff on the outside and put it together. And then I take the stuff on the inside and put it together. And that's my answer. This is just an alternate way of doing it the way that I was just doing it. My way's a little bit shorter, but if that's the way you learn it, do it. Don't try to, you can try to learn my way, but if you get confused on my way, go back to this, go back to what you know. We take a test in a week, so I want to make sure you get those right. All right, we'll see if we run into any more of those. And we'll definitely, the one thing good is we might do some of this Wednesday, and we might do some of this, we'll definitely do some of it Monday for the review. All right, what happens if you cannot factor? There are two different ways you can do this. The first way is probably the quadratic formula, which you've heard of. We'll do one of those in a second. The next way is called completing the square. Completing the square is not necessarily easy until you get the hang of it. But basically what happens here in this first topic is we're just going to come up with a magic number that makes us be able to factor it. That's what completing the square is. And that magic number, I guess a quadratic equation is always written like this, right? The a is in front of the x squared, the b is in front of the x, the c is a constant by itself. The magic number that we use to come up with this is b over 2 squared. Is b over 2 squared. So my b on this one is 10. 10 divided by 2 squared would be 5 squared or 25. All you're doing on this one is trying to come up with your magic number. That's going to make it super easy to factor. What multiplies to be 25 and adds up to be 10. 5 and 5, right? So we kind of manipulate the equation to come up with our magic number to be able to factor it. So just to do the magic number again, because the negative does matter on these, b over 2 squared. Negative 6 divided by 2 squared would be negative 3 squared, or 9. So 9 is my magic number. It multiplies to be 9 and adds up to be negative 6. Negative 3 and negative 3. So we are going to manipulate the equation to come up with the magic number to make it super easy to factor. Okay? All right, so let's go actually do a full one here. X squared plus 4x minus 5 equals 0. So that one factors. AI. Change this to like a 7. No, not a 7, not a 7, not a 7. 7 would be bad. 8. Sorry. Okay. Apparently I need to check AI a little bit more. They can't quite do math. All right. So what multiplies to be negative 5 and adds up to be 8? There's nothing. It doesn't factor, right? So what we are going to do is this number doesn't work for us. We are going to move it to the other side. X squared plus 8x. I'm going to leave a little space there if you're writing, because we got to come up with our own magic number. So I'm getting rid of that 5 because it doesn't let us factor. Now I'm going to do what we were just doing and come up with my magic number. B over 2 squared is 8 divided by 2 squared equals 4 squared is 16. All right, now the one thing about my magic number here is if I add 16 to the left side, I also have to add 16 to the right side. Because we can't change the equation. We're just coming up with a new number to make it easy. Okay? So I add 16 to the left, and that means I have to add 16 to the right. Now, my magic number, the way that works, is it is always going to break down to look like this. It is always going to come up to be like this. That's the way we set our magic number up to. Because what multiplies to be 16 and adds up to be 8? 4 and 4, right? But the shortcut to this even more is to say it's always going to be half of this number. No matter what, it will be half of that number. So this one always ends up looking like this. Okay? X plus b over 2 squared. You don't really need to know that because you can factor 16 and 8 pretty easily, right? But it will always be half of that middle number. And the sign goes with it. So if it's negative, it'd be negative. If it's positive, it'd be positive. And then we add 5 and 16 on this side, which is 21. And then my last step here, we worked a couple of these. You have something squared equals a number. So we do the square root of both sides. So you have x plus 4 equals plus or minus. The square root of 21 does not break down. You can't simplify that or anything. Here we subtract 4 from both sides, so we get x equals negative 4 plus or minus the square root of 21. That is my answer. Alex may make you do plus square root of 21 and negative 4 minus the square root of 21. So this is an alternate, I mean, technically you could use this all the time, but this is an alternate to quadratic formula, basically. So let's do one more of these. So we look at this and see, we say what multiplies to be 12 and adds up to be negative 10. And there isn't anything, right? 6 and 2, 4 and 3. So you always want to check to see if you can factor them first. So we are going to get rid of that 12. And we say x squared minus 10x. What magic number can we put here? And we got to put it on both sides. That 12 doesn't work for us, so we're going to come up with our own. b over 2 squared would be negative 10 over 2 squared, or negative 5 squared, 25. So I'm going to add 25 to both sides. All right, so to factor this, negative 12 plus 25 would be 13. This is this. We are always just going to cut the middle number in half. So negative 10 divided by 2 would be negative 5. And you can always check this. Negative 5 times negative 5 is positive 25. Negative 5 plus negative 5 is negative 10. And now we'll solve this like we have been. We can do the square root of both sides. The square root and the square cancel out, so I have x minus 5 equals plus or minus. Do not forget plus or minus. And then add 5 to both sides. So x equals 5 plus or minus the square root of 13. And that is two different numbers technically. The square root of 13 would be what, like 3.6. So it's like 5 plus 3.6 and 5 minus 3.6. All right, so completing the square is a way to solve it when it doesn't factor. The other way to do it, which you all are probably familiar with, is the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You may have to remind me, but on the test, I will give you these formulas. I'll even give you the b over 2 squared. I don't think you should have to memorize stuff like that. So I will definitely give it to you. When we do the review, it'll be just like the test. So we'll know exactly what's going to be on the test. So I'll know what formulas to give you. But the quadratic formula, you have to plug it all in. So a is 2, b is 3, c is negative 2. You always want to make sure it's set equal to 0 first. You really go through all your factoring steps here. Set it equal to 0, check for GCF, try to factor it. Yeah. Oh, so I thought you had a question. Actually, I think this one does factor. Let's change it so it doesn't factor so we can see. Let's change the b to 5. I'm sorry. I want the equations to work out different ways, so I want to make sure I get see everything. All right, so a is 2, b is 5, c is negative 2. We are going to plug it into the quadratic formula. The opposite of b, so it's negative 5 for b, because 5 is b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Now, what I do to make this look a little bit easier, instead of having to do that entire thing, I just pull this part of the square root aside. So 5 squared is 25. When you do this part, I would just look at it like negative 4 times 2 times negative 2. That would be positive 16. So include that negative right there with the 4. Negative 4 times 2 times negative 2. Would be positive 16. That's the square root of 41. So kind of pull the square root aside and work it out. And now I have negative 5 plus or minus the square root of 41 divided by 4. And that actually is my answer. Again, on Alex, I'm sure you're going to have to type it in like negative 5 plus square root of 41 and negative 5 minus the square root of 41. That is 2 different decimals. The only way you can simplify, hopefully they don't make you do that. We'll see. If we need to go over simplifying, we'll do that another day. All right, we'll do one word problem here to end it. A ball is thrown upward with an initial velocity of 32 feet squared from a height of 5 feet. After t seconds, it is given the equation. Oh, they give us the equation. We don't have to draw a picture out here. H, sometimes they do a function. Find the time when the ball is 10 feet above the ground. So our height is 10. That means we're going to plug a 10 in right here. Negative 16t squared plus 32t plus 5. So we are going to, we got to factor. You see a t squared and a t, an x squared and an x. You think factoring. So I'm going to subtract 10 from both sides. All right, check for GCF 16, 32, and 5. There is no GCF. You never really want to deal with a negative in front. So if you do ever have a negative in front there, you can divide it all by -1 and get rid of it. But since we can't, I guess we could check to see if we can factor it. Like you could, we can check real quick. So I'm gonna multiply it all by -1. 16 times 5 is 80. I'm sure we're not gonna be able to factor it. What multiplies to be 80 and adds up to be -32. Three, 4, and 20, 5 and 16. 6 doesn't go into it. 7 doesn't. 8 and 10. Yeah, I'm not getting 32, right? All right, so we got to do quadratic formula. Technically, you could complete the square if you wanted to, but usually when there's a number in front, it's easier just to do quadratic formula. So A is equal to 16, B is equal to -32, and C is equal to 5. So I'm going to do the opposite of B. B is -32, so I do +32. Plus or minus the square root of B squared minus 4 times A times C. All over 2 times A. Big numbers. Let me get a calculator out here. So 32 times 32 is 1,024. -4 times 16 times 5 would be -320. And be the square root of 704. So I have 32 plus or minus the square root of 704 divided by 32. What is the square root of? No. All right. I have no idea how they're going to want you to write your answer on this. They may just want you to do a decimal. This is the simplifying part that I didn't know if we'd have to do or not. But we can do one just to make sure. So I'm going to erase this right here to see if we can simplify. Why am I going blank there? Okay, to simplify a square root, just divide it by something small. Like, I don't know what that divides by. I'm over here, I got my calculator. What if I divide it by 4? That's 176, all right? 704 divided by 4. Divide it by 2 if you want to. And I get 2 and 2. 176 is 176 I can divide by 2. Just divide it by 2. Keep dividing it by 2 if you want to. Divide it by 2 is 44. Divide it by 2 is 22. Divide it by 2 is 11. Okay? Here's the easiest way to simplify square roots. Hopefully you won't have to do a ton of this, but that's called the factor tree. So 2 times 2 times 2 times 2 times 2 times 2 times 11. If I multiply all that together, I get 704. The square root is all about pairs, right? 3 times 3 is 9. Square root of 81 is 9 and 9. Square root of 100 is 10 and 10, right? So you're looking at pairs. So if I go through here and I say, okay, I have a pair of 2s, a pair of 2s, and a pair of 2s, they're all going to come outside the square root. So 2 and 2 and 2 come outside the square root, and 11 stays in. So this is actually 8 square roots of 11. So every pair comes out. If it doesn't have a friend, it stays in. We're ending on a hard one here, but and then the last thing here is I hope you don't have a ton of these. I didn't change it. Well, this is AI. If all 3 numbers right there on the outside are divisible by the same number, do never divide the number on the inside by the square root. Okay, that's inside. You only do the stuff on the outside. If you can divide all 3 of those by something, you can do it. So I can divide all those 3 of those by 8, right? So I have 4 plus or minus the square root of 11 divided by 4. Do not just like cross out these 4s. All 3 terms in there have to be divisible by the same thing. And that should be my answer. You all are going to get into Alex and get that problem, and it's going to be all just make you do decimals, and then you're not going to have to do any of that, but that's fine. All right.